Okay, it's time to get on to our last little bit here. I want to really get at, if you look at the outline, this issue C, receptor subtypes. And I'm going to go into a specific example here. The first product that came out, the first neurotransmitter that they really learned a lot about was the neurotransmitter acetylcholine. And I think there is some information in your book about acetylcholine. Some of the handouts, the Wikipedia handouts, are actually on track as well. I've read through them and such. So let me explain a little story to you about acetylcholine. It was identified very early with acetylcholine that when acetylcholine was released, there seemed to be in different spots in the body two different types of shapes of receptors, postsynaptic receptors that acetylcholine could bind to. And researchers were kind of puzzled by this at first. How could acetylcholine bind at receptors that kind of had two different shapes? But what they decided to do is they wanted to do some follow-up experiments with these two different receptor shapes or receptor subtypes. And so what they decided to do is they took these two receptors and they were able to isolate them, I believe put them into a petri dish and so forth. And in one of the dishes, actually they took these two dishes and they put nicotine, not smoke and stuff, but actually nicotine, the drug nicotine, into both of these petri dishes. And they found that when you put nicotine in one of these dishes, that the nicotine seemed to get bound to the postsynaptic receptor. It got bound really, really well. It had a high affinity. That's the word we use. It had a high affinity, and it really seemed to cause some strong biological effects at this one receptor. So when you put nicotine in, it was really well bound and had really good affinity and really good efficacy. So nicotine is actually considered an acetylcholine agonist because it mimics the neurotransmitter acetylcholine. But nicotine got bound really, really well to this one receptor subtype. For the other one, when you put the nicotine into the other one, it didn't get bound really well, and it didn't really cause a biological effect. On the other hand, they took another substance from mushrooms, muscarine. And when they took muscarine, and that's on another handout from a mushroom, if you will, when they put muscarine in, first to the cell that really got bound well to nicotine, the muscarine didn't seem to do anything. It didn't have a high affinity or high efficacy for the same one the nicotine did, but for the other one, for the petri dish that had this other type of shape in it, it seemed the muscarine got really, really well bound, had a high affinity and high efficacy for this other receptor subtype. Thus, they name these two receptor subtypes for acetylcholine, the one that had a really strong nicotine event, if you will, the nicotine agonist one, that was considered a nicotinic receptor subtype. The other one, that the muscarine got really well bound at, was considered a muscarinic receptor subtype. So it appeared at the very beginning for acetylcholine that there were these two receptor subtypes, and nicotine got bound much better at one of these, and muscarine got really well bound for the other one. And so these receptor subtypes are named for their agonist. And if you look at some of the text in there at the very top for each one of these, you can see that nicotine receptor subtypes work in a very specific way. It looks like they're mostly ionotropic, and it looks like for muscarine they mostly work with metabotropic mechanisms in different parts of the body. So it's very, very interesting. Nicotinic receptor subtypes are found a whole bunch in near the muscles. Before your muscles move, if you wave your hand, there is a neurotransmitter gap right at the neuromuscular junction, and it appears that acetylcholine is the neurotransmitter that is right there. And if you're wondering why I know this, I actually have a little story about this that's actually based on Raiders of the Lost Ark. Anybody ever seen Raiders of the Lost Ark? If you've watched the movie Raiders of the Lost Ark, in the very opening scene, you've probably seen that they have bows and arrows there. And when they have the bows and arrows there, if Indiana Jones was actually hit by one of the arrows, what did the arrows have on it? The arrows had curare on it. It turns out that curare is considered a nicotinic receptor. Uh-oh, I left the room. Sorry about that. I was trying to get the phone out of here. Whoopsie daisy. So let me try that again. I'm sorry, I should have been walking with this. So if you watch the movie Indiana Jones in the very first one, when they're running out of the cave, the Indians have bows and arrows, and they're shooting arrows, and the arrows have on the end of it curare. And as it turns out, curare, if it penetrates the skin, is considered a nicotinic receptor antagonist. And it'll go right to the neuromuscular junction, and what will happen? It will paralyze people so they can't move, and it'll kill people. So, as it turns out, curare is considered the nicotinic receptor antagonist. The other story I have for you has to deal with the muscarine receptor antagonist. It turns out that the muscarine receptor antagonist is a product called atropine. And there's actually a very interesting story that's related to one of my favorite artists of the 80s, Stevie Nicks. Does anybody follow Stevie Nicks? Long time ago, do you remember the name of her first solo album after Fleetwood Mac? It was called Belladonna. And it turns out that belladonna is a very interesting product. Women in Egypt used to take belladonna because when you take belladonna, that substance, as a psychopharmacological substance, would go into your pupils, into your eyes, where there's actually muscarinic receptors, and it would block the muscarine receptors. And you're saying, well, why would this be any good? Well, it actually makes your color in your eyes, your pupils, dilate a lot, and thus it made the eyes really beautiful. So as it turns out, atropine is actually considered a muscarinic antagonist. It can make the eyes really beautiful, and belladonna is that substance. So they used to take this substance, and if you know anything about Stevie Nicks, you know that if you actually took too much of this substance, it could kill you, because if you got an overdose on it, it would be very deadly. So it's the deadly nightshade, actually related to the tomato as well. So as it turns out, these receptor subtypes, as far as an issue, are very, very important, because if you actually found different receptor subtypes, remember what the big hope is? Could you actually isolate the receptor subtype, like we talked about with pain, with morphine and the endorphins? Could you just fix the problem at hand and have type reductionism and not have all the side effects? So there's a lot of research going on. If you look at acetylcholine, they've got lots of receptor subtypes now. Fix a receptor, fix a behavior, if you believe in this type reductionism. So this kind of summarizes this. I also want to say just a little bit of acoustic information about your follow-up assignment. What I would like you to do for this particular follow-up assignment, it's the one after the the basics here, see if you can find a drug. You can email me what the drug is. Maybe it's some drug that you've taken for mental health, maybe for depression, maybe for schizophrenia, maybe for epilepsy, some mental health disease. And then the idea is see if you can find a drug that's used to treat this. See if you can find out about its psychopharmacology and about its neurochemistry and even electrophysiology. And the idea is to type up a paper, maybe a page or so for a first draft, a page or so of what this drug is, how it works in your own words, so I can see that you understand that it's a agonist or an antagonist and this and that, and then say whether or not you think this would be a useful drug or not. So that'll conclude all this lecturing. Thank you very much for your time. Bye-bye.